longer due to some stuff that happened in the background, no worries. I'm going to talk about how to, or at least let system communicate using Azure Integration Services. So this will be a bit extension, a little bit bigger picture compared to the previous speaker who dived more into logic app connectivity and the on-premise data gateway. So I will expand it a little bit with regards to my session. Okay, so who am I? Just quickly introducing myself for those who might not know me. I'm a Microsoft MVP for over 10 years. I used to do a lot of integration with BizTalk on-prem boxed solution, and slowly migrating into building integrations in the cloud. So one of my first integration was with Salesforce back in 2010 with BizTalk, and then usually doing more like hybrid and cloud integrations. I'm a technical architect at HSO, which is a Dynamics partner, ISV, doing a lot of Dynamics implementation. So I'm also involved, but then more from an integration perspective using Azure Integration Services. So I'll talk about that. InfoQ Cloud Editor, so I write a lot about cloud technologies, not just Azure per se, but also Google Cloud and AWS. In general, this is a website, infoq.com, which you can find online. It discusses many cloud technologies, but also programming languages and so forth. So there's a lot of things you can find there. Organizer of the Azure Lowlands, which is this year was a virtual session. Once a year we do this one day. Also part of the Azure User Group in the Netherlands as a board member and also a writer for serverless nodes. So that's in a nutshell. I also like to do runs, so half and full marathons, although due to COVID I haven't done many of those races. I do exercise a bit, but yeah, I'm looking forward to do one more marathon at least in the time to come when things open up again, I hope. Okay, let's further ado. Let's look into the story outline. So what I got for you guys. So I'll talk about integration in general, architecture, some examples, best practices. I'll also include Power Automate, and I will explain why that is, a little bit of the market view, takeaways, and so forth. Okay, so I've got a little story about, Tower of Babel. So you might wonder, okay, why is he going to start about the Tower of Babel? Well, it's kind of set in the context. So back in the day, there was this one people, according to the Bible, they just moved around the world. Then they basically came to one city, and they kind of, started building, a big tower because they wanted to reach heaven. God, though, didn't find that it was an interesting idea to do this. He kind of disrupted this work of creating this Babel all the way up to heaven by disrupting it through letting everyone speak a different language. In this way, the tower never completed. So, people dispersed, went around the globe, and this is why we kind of speak different languages. This is, by the way, a painting of a Dutch Fleming called Peter Bruegel the Elder, which, they make this picture. So different languages, different people. Let's just, take this analogy and take systems instead of people. So modern tower, the Burj Khalifa, just an example. But you got all these systems, right? And they all, talk differently in some manner because they're different entities and, they're just totally different from each other. But all these systems together, or some of these, could be your best of breed solution to support your business processes today. And these systems are here because of the rise of the cloud. So Sales was one of the first, of course, and many other SaaS solutions came into this cloud world as we know it today. And these systems basically support some kind of role, even if you've got like your systems going in the cloud, or some of them to support your business processes. It's either finance, HR, you can think about field services, storage, ticketing, logistics. Many of these services could be part of your best of breed solution to support your business processes. So these systems, of course, then need to communicate with each other. So going forward, let's just look at the application landscape for a bit. So you have those systems. Back in the day, it could be on-prem systems like SAP, mainframes, etc. All tied together, maybe with a box product like a BizTalk server or other type of solution, connecting those systems. Going forward, though, with the rise of the cloud, and still some systems still on-prem, you get this hybrid type of solution where systems are dispersed, not just on-prem, but also in the cloud. And potentially going forward, and this is kind of going and looking into the future, presumably might be all these systems might be in the cloud, or maybe on such appliances like Azure Stack, or there's other solutions from cloud providers where appliances roll into your building as a mini kind of cloud where you have those systems, and then with or without connectivity. But in the end of the day, it might just run on cloud or cloud technologies. So that's what you see here. So the journey of integration and a system. So back in the early days when systems were on-premise, you had BizTalk Server, which came in 2000 as a box product, allowing you to do the system communication and tying systems together. Going forward with the introduction of the cloud and the GA of the cloud, Microsoft kind of thought, okay, this technology we have on-prem for system communication integration, we want something similar in the cloud. So they started with Service Bus, AIE, and EDI Labs. The first iteration didn't really succeed, never came to a good fruition or GA. Then they tried BizTalk Services for a while, which was the second iteration of technology similar to BizTalk Server. Then going forward, they came with Logic Apps in 2015 in March with a preview, and then you got a G8 in July 2016. So this is a journey, and BizTalk Server and Logic App both are in GA, and they're still present and used today to support system communication, integration, and the support to business processes. So yesterday, you had your box product. If you do the same analogy with what you got yesterday, today, and tomorrow, you got your BizTalk Server. BizTalk Server can tie into the cloud using different adapters or connectors, if you would say, leveraging also, for instance, the on-premise data gateway technology, which you just saw in use in the previous session. And then you tie into Logic App as kind of a gateway into all these other Azure services. Then going forward, or even what you can use today is these technologies available in the cloud, which are Service Bus, API Management, Logic Apps, Event Grid, which are kind of making up this Azure Integration Services. Okay, that's it. So we talked a bit about, okay, we have new systems, systems that have been, offered as a SaaS solution. And how do we let those systems communicate and exchange data with each other, right? You need some integration tag. And this integration tag, and I already mentioned this, is Azure Integration Services. So these are just 4 standalone type of services available in the cloud, but they're just bundled together as a suite of Azure Integration Services as Microsoft markets them. So you got your Logic Apps, provide supporting of business processes through workflows and connectors. You got your API management, which is kind of a gateway that can sit between those APIs, either provisioned and hosted in the cloud towards communication with third parties, being an intermediate, supporting security and such, and I will talk about that as well. You got your Service Bus. This is one of the oldest services available in Azure. It had a few other names in the beginning, even one name I think included BizTalk again. It's now a Service Bus. It has it's a mature service, and it provides this loosely coupled way of having systems communicate with each other. And third, or at least a fourth service which came into the picture and has been out there for 2-3 years now, is Azure Event Grid, based on similar mechanisms as Service Bus, which pops up, but a bit different and more geared towards events. Okay, let's discuss some of these technologies and some of the characteristics and some of the things I think you should know about this. So one of the things, of course, is a Logic App, and as you can see, it can tie into many of the services through connectors, SQL, Azure, Dropbox, Salesforce. Through an on-premise data gateway, you have this connectivity to on-premise systems, SQL Server files, even BizTalk Server. So the BizTalk Server Logic App connector meets the on-premise data gateway to get this connectivity going with the Logic App. And through API management, even if you have self-hosted API management, so you can have API management instance running on-prem, you can expose some of your APIs and consume those in a Logic App. And the other thing I'm mentioning here, you can also build some smart solutions with cognitive services because of the connectors available in Logic Apps. So the big thing about Logic Apps is, one, of course, it has a capability of running a workflow, but for that you need the connectors. So there's hundreds of connectors available. They're SaaS on-prem. It provides you some of the hybrid connectivity and such. So that's one way of leveraging the connectors available in Logic Apps. The other thing is custom connectors. So the previous session did a really thorough walkthrough on how creating custom connectors and how it can provide some value for you as well if perhaps the managed connectors from Microsoft or other connectors aren't, the managed connectors Microsoft basically build for you are not sufficient or doesn't support your needs. Then there's a way of creating those custom connectors. A third option is through API connections. So your proxy connections in your API management instance are also able to be consumed inside your logic apps. So there's another way of connectivity towards your logic apps. Okay, I think you should know about this, and this is kind of interesting about logic apps, is what's actually under the hood, right? So there's basically 4 components. There's a resource provider that is in logic app architecture, which breaks down the definitions and does this decomposition for you. One end, you got also a logic app runtime, which basically executes the workflow. You get your connector manager, which basically manages the connections, credentials and such. So because those connectors kind of depend on connectivity, and also the abstraction of an OPN API specification. Most of those connectors in logic app are basically wrappers around APIs. And you create them customly using the custom connector. Okay, so as you know, a logic app consists of a trigger followed by multiple actions. Similar to other workflow solutions, even back in the day with .NET, you got Windows Workflow Foundation. Similarly, it consists of a trigger followed by one or multiple actions, which consists your complete workflow. You can do this by just dragging and dropping your trigger followed by multiple actions. So this is a view of your logic app designer, which can be in the browser, but also in Visual Studio. Once you save your logic app, it's your workflow definition based on, if you look in the code behind, you got this domain-specific language of your workflow, which is JSON. This workflow definition can be triggered once a service enters the service bus, and there you get this trigger task. So this is one of the many tasks under the hood. And this trigger task basically sends that message to an orchestrator flow. So this all happens in the background in the logic app runtime. Subsequently, it will break it down. It will interpret it. That's done by the resource provider, and it provides this interpretation. Hey, you got all these actions, inserts which can run in parallel. Being that this message from the service bus contains many order lines, for instance, does this insertion and completes the message. These are all kinds of tasks which can run in parallel. And then it will complete the message, or the workflow basically is being completed. It's broken down in all kinds of tasks. So there's no thread management or whatsoever. It's just all kinds of tasks. Of course, there's initial task followed by many other tasks. And these, because of the breakdown, are being distributed in this data center somewhere in an Azure region. And there's at least one guaranteed execution of those actions. And if it doesn't work out, if a piece of hardware in the data center doesn't work, it will distribute this to another part of the data center. So this is all done by the orchestrator. And if you communicate with other parties, and when you have some DNS issue or throttling, by default, some of these actions provide retries. So this is also done under the hood, depending on your configuration of your action. So this is the consumption model when you run logic apps, in your Azure environment. You can also, like Azure Service Environment, which is our application service environment. So this isolation of your compute. So you can have this isolation environment for your logic app. So you get your runtime and you connect your runtime all by yourself. And because this is more enterprise geared, it also supports VNet and ExpressRoute and so on. So you can have a better bandwidth going into your on-premise systems instead of the relay, which is kind of part of your on-premise data gateway, which has smaller bandwidth and maybe less stable by the fact that you need to install some software on-prem to provide availability. And this is better secured with ExpressRoute, but then there's also another pricing model geared towards, because it's enterprise with all kinds of enterprise capabilities. And the latest development, so this is from Ignite 2020, so it's at the geared towards, I think, November, October timeframe, when the product group kind of announced, hey, there's another way of hosting your logic apps, which can be done in the app service runtime. So it's like functions run in the app service runtime, so you can build, host, and test them locally. You can do something similar with logic app and even containerize those and provide the ability to run them on AKFs. So it's either shared runtime, where you can just use the way logic apps are today, or you can use a dedicated runtime with ICE, the integration service environment. And then going forward, this logic app in preview provides you the ability to run stateful or stateless logic apps, and also containerize those, giving you all these options. And the URL you see here provided is a blog post by Tom Kirkhoven, a former colleague of mine, who basically dives into this material saying, hey, you can, or this paradigm, like you can run logic apps in different ways. Okay, part of your Azure Integration Services suite. So I dived a little bit extensively into what logic apps are, some of the runtime, and the important thing about the connectors. And then you got this other part, which is the service bus. It's a managed offering inside Azure, allowing you to provide reliable, stable, robust messaging asynchronously and synchronously with other systems. So it's kind of a, it provides entities like relay, queues, topics, and subscriptions. It enables you to do hybrid solutions because you can push data from on-prem through to a queue or a topic. It is compliant with other of the other protocols like AMQP. It supports semantic like first in, first out, dedubs, transactional behavior. There's a lot of things out of the box with a service bus. And it mainly consists of 3 parts. So one being the service bus relay. So this is one of the capabilities available in the service bus for quite a time. And as you can see, it will allow you to do two-way communication with, a service. And this technology, this relay technology based on outbound connections and this rendezvous inside the relay is the technology which also is a part of this on-premise data gateway. The other part it offers, or another entity, is a queue. I think you're very familiar with queue, message queuing, RabbitMQ, on-prem, like all that stuff. There's similar capabilities available on Azure. Few queues, so one or multiple message producers could send something to a queue where there can be only one consumer. If you want to have one or multiple parties sending messages to the service bus, it can leverage something which is called a topic, which is an Uber queue, which can have multiple subscribers. And then you get this pub-sub type of concept with the service bus and the decoupling of systems. So they can send messages, they can wait for a while and pick the message up. So it's also very useful for store and forward finding kind of scenarios, or where the consumers cannot straight away consume those messages. But you want this durability, you want to be sure that those messages will not be gone. That's something your service bus will guarantee for you. Subsequently, there's another capability, which is the event grid, which is kind of the backplane within Azure, supporting managing of events, similar to this pub-sub type of architecture, but instead of pushing and pulling messages, it's pushing events towards one or multiple subscribers or consumers of those events. So these consumers can be Azure or non-Azure resources. It allows you to do more near real-time processing of your data with the fact that it's a push-push model. It's lightweight, it's low cost. There's Service Fabric on the hood. It's one of the more serverless services you can find in Azure. And the concepts are pretty clear. You got your event sources on one end, which are various of the supported Azure services in Azure. Not all of them. For instance, Cosmos DB doesn't support this type of technology. It uses the change feed. There's custom events you can send out of a custom application in .NET, or you can leverage what's called a cloud event, which is something different, and I will explain that later as well. Events are being pushed, and there's multiple handlers behind it. So it could be functions, it could be logic apps, through under the hood webhook setups. It could be that you push your events to an event hub or storage queue for later consumption or later processing. And there's other applications like hybrid connections or webhooks or other Azure automation that can, consume those events. And what happens is that all the events are managed in one place. It's inside what's called a topic, and that's where you can say, okay, I want to subscribe to these types of sources. I want to apply some of the filtering, and I want, and you can this way set up your handlers on the other end. Concepts, again, are pretty simple. An event is something that happens. It's a fact. Publishes where the event took place. They're being published to what's called a topic. So that's where the publishers send those events to. You have your subscribers, which will receive those events and subsequently handle those. And those events either adhere to what you see on the left-hand side. There's a proprietary schema from Microsoft, which has some elements in there, including the data. The data element contains the data itself off the source, but you also have this cloud event schema from the CNCF, the Cloud Native Computing Foundation, which has a set of more industry standard, but the concepts are kind of similar, where you consume the event and use some of the information you find in the data elements or the data property. So this is all about event grid. Again, this is more real time based also on pops up with a push-push model versus something you have with a queue, which is push and pull. And then the final part of Azure Integration Services bundled together is what's API, and that's kind of what API management is. API management is this broker intermediate product available in Azure, and it can be a gateway of all kind of your Azure services like logic apps, APIs you host in an app service, and functions. What it basically does, and that's what it says, it's a hub for enterprise applications or APIs. So you got your API manager developers on one end, and you got your app developers or consumers of your APIs on the other end. And bringing those together, you have this intermediate product called API management. So on one end, you can have someone creating proxies, like abstracting an endpoint or creating a proxy in this intermediate product, API management, to expose this to the consumers on the other end, which can discover, try and learn about your API. So you can view it as a kind of a facade and front door. So I have an API on the other end, which could be a hosted API on an app service, could be a logic app, could be a function, and so forth. I create this proxy, which I can subsequently expose to my within another department, could be third party, and I can also use the DNS name, or I can change this. Hallo, zet de dingen uit. Excuse me, I'm in the room with someone else. So I can route that information towards a proxy which has multiple operations which are tied. Each operation can be tied to one or multiple functions or logic apps. So this way I can make kind of a composable API and expose this to my third party. Magic behind it is that within and outbound traffic towards these background APIs are policies, which allows me to do validation of Java tokens, rate limiting. I'm not allowing these APIs to be called. I can do control flow, I can do retries. Sorry, how is it op, joh? Sorry. You can apply scopes and stuff, so you can influence your in and outbound traffic, and basically from your backend services move some of the quality service aspects towards your intermediate, towards your proxy. What you can see, this is the code behind of your policy. So there's inbound, there's backend, there's outbounds, and there's even on error, which is kind of, you can place some of the policies in on error to do some error handling of your policies in some of the other areas. To look at policy scopes, and I think this is an important part too, where can you place those policies, how can you influence those? You can put this locally, globally, so you can, all the logging and course aspects are basically applied to all APIs in a product, and a product is just a container of, logically separating APIs towards your end consumers. And within an API, you can have multiple operations. So you can do rate and quota limiting on your APIs inside product. You can do Java validation of your API, meaning that every operation needs to do this Java token validation. And then within an operation, so you've seen how fine-grained these policies are, you can do some caching, URL, and a body. So from the caller, you get like call a endpoint. You provide a key. So within a product, you can also enforce the fact that you have to provide an API key, which does provide you some authorization capability. This is your API, and this is your operation. So to conclude, these are, those four services combined are your Azure Integration Services. And with this, let's look more from a solution architecture perspective with these technologies to provide solutions where you can have systems exchange data and let business processes run. So from an architectural perspective, so I'm zooming out, you have kind of these layers and stuff with regards to your integration solution. So you got monitoring, you got your ALM DevOps aspect, you got your infrastructure, which is your Azure environment, you get some security aspects, and then you get this like, you get your APIs, which could also include API management, your integration and messaging. So this is kind of you can see this as an architecture kind of reference architecture. So, and within this, you can see that there's many types of responsibilities you can find in those layers. So you got your routing and your messaging, you got your connectors for your integration, you got your APIs, monitoring, you got things like source control, you got access control auditing, you got with networking, you get things like high availability and etc. Going forward, this is where I can plot many of the Azure technologies, including the Azure Integration Services. So you find your messaging with Service Bus and Event Grid. You find your integration with logic apps. You can also have Data Factory, but this is more for bulk data and extract loading and extract transformation and loading capabilities. And then you got your APIs with functions or API apps, but you can also have your API management doing this proxy, this intermediate front door possibility. With that, you got your monitoring capabilities with App Insight, Power BI, you got ALM with Azure DevOps, you got your infrastructure with networking and ARM templating, and you got your security through Active Directory, Key Vault support. So for instance, when you try to secure a backend, you get your proxy and API management, but it goes to a backend capability. You can have these mutual certificate or SSL setup. You need certificates. This is where Key Vault comes in to support you in that. And the other thing is, authenticating to your application, you can use Azure Active Directory. So I talked about the tech, the solution architecture perspective. How does this work in real world? Okay, so you talked about this, but how does this, how is this reflected in real world? So I've got some cases which I worked on. So this is one of the cases where you have an on-premise system tied to BizTalk server. So the BizTalk server provides the connectivity with a warehouse management system and many others, and maps the workload that needs to go all the way up to Dynamics Finance and Operations, which is now called Dynamics Finance and Supply Chain Management. But 2-3 years ago, it was still Finance and Ops. Under the hood, it's still the same application. That mapped workload, which is an XML, is being pushed towards a logic app that's secured by API management. So the API management has a kind of an IP address, which through IP filtering in your logic app provides some type of security. That workload is subsequently being pushed again through an API management towards Dynamics 365. So Dynamics 365 exposes an endpoint which is secured through API management. And you could apply some logic in a policy to do further mapping if necessary, just as an illustration or example. And that workflow basically is an XML file that's being sent to a recurring job within Dynamics to be processed. So this is a hybrid type of setup where this company started to work with Azure, or wanted to have this cloud journey, and started saying, okay, hey, we're going to decommission our on-premise ERP system and change and replace this by a Dynamics 365 solution in the cloud. This is a more cloud-native solution where you have Salesforce and ServiceNow. And this is more a event-driven type of solution or integration where these systems need to be compliant and consistent with each other with regards to data. So we chose to use Event Grid for near real-time synchronization of data between those systems. Salesforce pushes out an event which is pushed towards a logic app, again secured by API management. This is a more generic event which we map to a proprietary schema event, which I talked about earlier. It's being pushed towards Event Grid topic, which has one logic app sitting behind there, or you can have multiple logic apps depending on your events and entity chains within Salesforce. And having that event, it will inspect in that data element. It will look, okay, this is the identity of the identifier of the identity. Let me just fetch the rest of the data. So the rest of the data is being fetched by a call through API management to Salesforce, where there's an inbound policy placed on the API level, providing, or at least going to Salesforce first, getting a token, which subsequently has to be put in every operation towards an API exposed by Salesforce. It will return data in JSON data, which through a liquid template, we map towards a response that's being pushed back to a logic app, which subsequently pushes that to ServiceNow, where another part of mapping is taking place towards the entity which sits in that end and has, of course, a different structure and format. And this is how it works. With regards to system communications, whether it's on-prem, hybrid, when it's, what I just showed you, the magic basically is, and this comes back to the story about, when you talk English, you have to do some type of transformation to your native language or vice versa. This is all transformation translation. And this is kind of the magic with system integration, with all these systems with different objects, formats, etc., enabling that communication. And if you look from a tech perspective, you can either use an integration account, which is another service in Azure, which is kind of a wrapper, or at least a service that allows you to push schemas and transformations to, so allowing you to do transformations, either XSLT or liquid, or it even provides some of the EDI capability as well. You can use an API function, you just do the mapping yourself using .NET, or you can do this within your API management policy. So your formats can either be XML, XSLT transformation, it could be JSON Liquid. So Liquid is an open source capability or mapping technology from Shopify, which allows you to do JSON mapping or JSON to text or vice versa with XML, XSLT. There's also capabilities of mapping this from one format XML towards text, or you can even from XML to JSON. This is a capability. You can also find a logic app to do that transformation for you. Or the other thing you have to refer to is just using custom.NET. This is one part which is important. The other part, which is important in general, when you create an Azure Integration Services and having the system communicate with each other in some way or form, is that you want to provide some loosely coupling. You don't want to have tight coupling. So this is the ESB concept coming in as well. You don't want to have this spaghetti going line to line and having each system directly communicate with each other. You can put something in the middle, which is this kind of enterprise service capability, but then you provide it, as I showed you earlier on with this Azure Integration Services, leveraging logic apps, leveraging queues or event grid. The other important thing is about monitoring. I will dive into those aspects too. Think about monitoring, think about event-driven, think about cost management, because most of your parts in Azure are services that are consuming basically resources in the data centers, which might well bills you for. Think about versioning, put governance in place, who can touch what, because you're also moving data around, so you have to be compliant with GDPR and such. And the other thing is think about automating your solution as well through Azure DevOps. So with those best practices in mind, just revisit some of what I talked about earlier. So this is that cloud native event or cloud native integration. I got Salesforce, I got ServiceNow in this picture, and I got Azure. So I need a Salesforce admin, I need a ServiceNow admin, maybe I need some consultancy to do some customization within those solutions. And I got an Azure admin that has to overlook the integration as well, using a portal, using OMS, through Log Analytics Workspace. So that's on top of this. If you look under the hood, because it's hosted in Azure, you have to think about Azure monitoring, alerts, and metrics, cost management because of consumption of your services. So you have to keep an eye on that as well. With API management, for instance, you can do this Azure Active Directory integration, or RBAC. Think about Key Vault with secret management. With Event Grid, it's important when you have those subscriptions that if it's unable to deliver those, you have to enable dead lettering, and then you need a storage account. And with regards to API management, you can think about subscription keys, about the API definitions, the policies and such. So those are all aspects you need to think about, also where you're going to put the mapping and such. And as a developer, you will provision some of the services you will reuse, like an API management instance, like an event grid, like a service bus, namespace and such. So you will use infrastructure as code, using a repo, using YAML pipelines to get that done. And then the other thing is that you also will create logic apps with definitions and workflows, which you also subsequently through your repo will push towards different environments in the cloud. So having UAT environments and production is also important. With regards to monitoring, so I mentioned already that you can monitor this using Azure Monitoring, and you can set up alerts on the performance counters of some of these services, but what about functional monitoring? So what if messages go from A to B or vice versa? So what you see here is an illustration of doing some central logging of metadata towards pushing all that data to a service bus topic, which subsequently can have one or multiple subscribers to it, consolidating that information into Cosmos DB, which is subsequently indexed, providing you some endpoints which you can leverage in a dashboard and gives you some information about your flow from A to B, for instance. So you need to consolidate all that metadata or some of the data centrally to provide you a good overview of your system communication and your information flows. Other aspects when it comes to a hybrid kind of way is that you have to, again, think about Azure Monitor, because some of your parts are in Azure. Cost management, you might need some monitoring capability on-premise as well. With your API management, in this case, you have to think about subscription keys, policies, and so forth. Automation, again, as you see depicted here, so it's some of your parts which you reuse over and over again, so that's your infrastructure over your environments. Your logic app definitions, so those all are being automated and using YAML pipelines. And on-premise, with regards to BizTalk, you can use something like the BizTalk deployment framework, providing you some application packaging and also automated deployments. Now, since we're talking about system communication and leveraging Azure Integration Services, I also want to do a step aside because there's another technology available allowing you to do some integration as well. And this is Power Automate. The reason I mention this because it has this capability which is called Robotic Process Automation, RPA, allowing you to get data out of systems that don't really have an API or such. If it has an API, of course, you will try initially to get data out of those systems, leveraging the APIs available. If not, then you can use this robotic application type of technology by recording task, automating task, and play back the task. And it uses some technology behind which you might know, like something like Selenium, because of your recording. So through UI and the UI Power Automate connector, you can kind of launch the recorder, record your click steps, and then kind of build up your flow. So this is how, in a nutshell, a little bit. I haven't touched this much, but I know this is kind of the way how it works. And then you can do something similar, which is like screenscaping back in the early days. So I have a little small video, and you can find it on YouTube with that URL. This is done by a friend of mine, Ken Weir, who is a principal program manager for Power Automate, really going into this RPA technology. So he's created many videos around it. And what you see here is just a closed system where he touches upon some email, getting some values out of it, and diverts them or automates it by placing the data into an Excel sheet. Okay, now with Power Automate, on one end, allowing you to do some automation depending on your scenarios, you can also have logic apps and functions. All of them are tied into this overall picture which I'm showing you here. The reason I'm showing it is because you can create Azure functions which you can consume in a logic app or consume in Power Automate. You can also consume a logic app through a function, or you can choose to provide more capability into your flow by pushing that Power Automate flow towards logic apps, giving you more control, etc. So you can extend your Power Automate flow if necessary towards logic apps. So Power Automate is definitely something that a power user will use within his Microsoft Cloud realm, I would say, automating tasks. When it's more about Azure logic apps, it's more about the system communication, right, with those connectors and such. And this is where you can find logic apps. And function sits a bit in the middle with customizations you need, or something that may be too complicated to do in a logic app or Power Automate. And then you can leverage Azure Function by basically coding in .NET or another language that's being supported through Azure Functions. Okay, that's it. So let's look at, in general, to the market. So what do analysts say about this Azure integration technology, and maybe even, what the Power Platform offers? Is this really serious? Is make it, let's zoom completely out and complete marketplace with all these SaaS providers providing similar solutions for integration and such. So this is when I refer to a Gartner report about integration or application platform services. integration platform services. So Logic App, or at least Azure Integration Service, you can see as an integration platform as a service, because these are all PaaS services supporting you in your integration with other systems. And as you can see, it's a leader. It was a leader, I think, last year and the year before that as well, comparing to some of like MuleSoft, which is part of Salesforce. You got SnapLogic, you got Boomi. Some of those are more box products that don't have a complete Azure platform behind it. So I would say Microsoft, from the big three cloud providers, Google, AWS, are, leading. It's not that, AWS doesn't have something similar in place, but it's not as sophisticated and mature yet as what Microsoft is offering. So it's pretty serious technology if you look at Logic App, but also the API management is within another leader quadrant, with API management as such, also one of the leaders as well. Which also brings me to the API management. As I said, it's also one of the leading technologies now in a Gartner report last year. So it now also enters the leader quadrant, and it's competing with some of the other technologies like Kong, which is an open source API management. You got IBM X-Ray, but also Google Cloud Platform does have a very strong capability in the forms of Apigee, which they purchased in 2016. But again, Microsoft offers pretty serious tech, which you can use in your integration solutions. If your company or if your customer is standardizing on the Azure platform or cloud platform from Microsoft, it's serious tech. Similar accounts for the low-code platforms with Power Automate, but also Power Apps. It competes with some of the systems like OutSystems and Mendix. You probably, if you're in that space, familiar with that. But again, Microsoft is a serious competitor, and also in the leader quadrant from that aspect. It kind of brings me to the end. So I talked about Azure Integration Services in general and some of the other tech, and I think you have to choose your technology based on your requirements. Where do you need that tech for? And if I look like the tech which I discussed, you got Power Automate, you got your Logic Apps, you got your Azure Durable Functions, which is something which sits in function itself since 2.0, which allows you to do workflow as code. But those are not competing technologies. Similar to Event Grid or Service Bus, it depends on your scenario. If you do near real-time processing, then you need this kind of event grid mechanism, or at least which I showed you, to get this done. But also loosely coupling, enabling asynchronous COM, you can use the Service Bus. And what's actually key is that you really understand the technology on one end, but also your process and some of your non-functionals, because that's all key in using one or multiple of these technologies for your integration solution, and enabling, if you have a best-of-breed landscape, allowing all these systems to communicate with each other, supporting your business process. And the other thing I want to mention as well is apply the best practices, and you can find those in the Azure Well-Architected Framework. So this is a framework available through the Azure Architecture Center, I believe, or at least in the Microsoft Docs, providing you some insights with security, operation excellence, and support. This is also why I mentioned those in the best practices early on as well. And that source, that Azure Well-Architected Framework, really can help you also when you're setting up integrations with systems. Sources to explore. So I will later will also disclose where I have the slide deck. It's somewhere up in GitHub. I already uploaded it, so you can have your Azure Integration Services. You have your serverless nodes, the Well-Architected Framework, coded blogs. So Coded is a company I used to work for. They have an excellent blog where you can find lots of information. You get your Power Automate, integration patterns, Learn, where you can find a lot of things. And the other thing I want to add is that I recently also wrote an extensive ebook about Event Grid itself. So if you want to dive into this technology, there's even a hands-on lab type of capability or instructions in this ebook as well. So you can download this and learn a bit more about the technology and what you can do with it. And finally, I also want to thank, I think these are all the sponsors of this event. So ScriptRunner, Microsoft, Docs42, Solgari, Pact, and DCG. All these guys are probably, and also the organizers are, basically behind this great event, and all the other days that, are also part of the Global Azure Automation Bootcamp. So I want to thank those people and everyone behind the scenes as well, and also you as attendees. So I'd like to thank you for attending this virtual session as well. Here are some of my details, so you can find me on LinkedIn, on Twitter. You can shoot me an email if you haven't got a question now, but maybe later on. MVP profile, you can also click on the InfoQ editor thing, so you can find some of my articles I wrote about Google, about Amazon, AWS, about Microsoft. So yeah, this is it. 45 minutes. I think I covered it well. We got some 15 minutes, I think, left for some Q&A. So I will have a look at the chat window and let's see. And let me just go scroll back. Let me have a look. Time to time, when I run into Power Automate, the error would have the word logic app runtime. I'm not sure if this is the question for me with regards to logic app and Power Automate, so I'm not sure if I could answer this. Let me just further look down. You didn't mention a lot on data gateway. Do you think that we can omit when integrating with other services? Yes, there is another capability because you can also have API management as a self-hosted capability and then expose some of your on-prem endpoints through that and then have that connectivity to the outside world. The other thing I would say, yeah, you can use the on-premise data gateway and the other capabilities. This regards more to networking. So it could be site-to-site or point-to-site VPN type of capability or enterprise or using ExpressRoute, but then you have to refer to, when it comes to logic app, or some of the capabilities with VNet integration and such. Yes, thank you for some of your feedback saying you like this. Can we create reusable solution for Power Automate? Not sure. I might have to owe you an answer on that one. I haven't used Power Automate too much. The only thing I'm touching it in this presentation is because the integration capability to have when it's a closed system and then you use this RPA type of capability. Back in the day with IBM mainframes, I used technology like screen scraping, and this is similar where you use Selenium. Where do you think on-premise data can fit in the integration? How can it be orchestrated in the business process? That's an interesting question. Depending on bandwidth, your frequency, because if you're using on-premise data gateway, you kind of have to, if you want availability, install it on two systems, because then they kind of leverage the similar gateway. I've done this also with the BizTalk relay adapter, because we had two BizTalk instances, both basically running, and one of the two can pick up the message and send it through that relay, but it all depends a bit on your bandwidth, frequency, load. I know some of my former colleagues also complained a little about the bandwidth, because it's kind of a small pipe towards when you have an ExpressRoute, you have a big pipe. So that's kind of the thing you have to think about this too. I don't use on-premise data gateway that much, although in the near future, though, I now have to push some of the flat files towards a file location somewhere. So this is where we're definitely going to use the on-premise data gateway, but this is on low frequency. And I don't see any other questions. Like I said, my details already. I will put in the chat. This is the chat. You find the GitHub location of this, a slide deck. So you can click on the links if you want. So you can find those details there as well. And I don't think there are any more questions.
Thank you, Steve, and a really great pleasure for you to join us today. Really great way to bridge the gap between all the different technologies available. So thank you so much, Steve, for sharing your insight. It's great also to see some of the use cases you shared. Lots of people from this community are from the Dynamics community, so it's great to see some of the use cases you showed with FinOps and the others. Everything you mentioned today is very highly relevant and used on nearly every single project. If you're working for any kind of mid-sized project or above, you're guaranteed to run into the patterns that you've described today. So I think it's highly insightful and valuable to everyone. Thanks for sharing your contact details in the chat. That's great. You've shared your GitHub. Feel free to share any other contact details, Steve, as well, if it's LinkedIn or Twitter. That would be really great. What Steve is showing on his screen, these are the prizes we're giving away. Okay, so the speakers will all be getting prizes by default. because thank you for your contributions to the event. You will be getting your hoodies and all your swag that will be on the way to you next week. But you can also win these prizes as well. We've got over 10 printed copies of the Power Apps Cookbook and the Power Automate Handbook. You can see on Steve's window being given away by Pact Publishing. We've also got electronic copies to give away as well. Yep, we've also got electronic copies to give away today. We're giving away all of these at the end of today. We've also got other merchandise like hoodies and cups and caps and bags as well that we'll be giving away. How do we give them away? By people who are the most interactive, who's been most engaging on the community. I shared a form earlier in the email. I will share the form again in the chat window. If you haven't completed it, please do, because we do have lots of prizes to give away, and we haven't given away anything yet. Okay, so there's lots of opportunities for that. So again, there's a big, great thanks to Steve for joining us all the way from the Netherlands today. It's a great pleasure. It feels great to be part of a global community, Steve. So thank you for all your contributions. And yeah, hope to see you soon. So that was Steve, everyone, from the Netherlands. Please make sure you connect with Steve. You've got his connection details there. Please make sure you connect with him. And again, big thank you to Steve and Flora.